Now it's your turn to use the rules of exponents to simplify expressions that contain rational exponents. Stop this video, take a moment to write out your answers to these problems in your lecture outline packet, and then turn the video back on to check your answers. In this first example, we have negative 64 times s to the 15th, and that's all in parentheses, and raised to the power of negative 1/3. The first thing we can do, there are a number of ways that we can approach this, but the first thing that we could do is to get rid of that negative exponent on the very outside and turn this into 1 over that whole expression, negative 64 s to the 15th raised to the 1/3. So instead of having a negative 1/3 power, I have 1 over that expression to the positive 1/3 power. Now, I can apply that exponent of 1/3 to each of the things inside those parentheses. There's a product there, right? So we're going to have negative 64 to the 1/3 times s to the 15th to the 1/3. And again, that's all in the denominator. I still have a 1 in the top. To simplify each of these parts, I'm going to take a slightly different approach. The first is a number. To simplify that 1/3 exponent, I'm going to use a radical. So I'm going to turn that into the cube root. Instead of negative 64 raised to the 1/3, I'm going to turn it into the cube root of the number negative 64. Separately, with s to the 15th raised to the 1/3, I'm going to turn that into s to the 15 times 1/3. Now in this next step, it'll become clear why we took different approaches with each of those. So I have 1 over, and then in this denominator, that cube root of negative 64 becomes negative 4. And that s to the 15 times 1/3 simply becomes s to the 5th power. So now I have 1 over negative 4 times s to the 5th. In general, we do not write negatives in denominators, so that negative can come out either out front of the whole expression or into the numerator. So I'll put it out front, and I'll have the negative of 1 over 4 times s to the 5th. Looking at our second example, we have the expression 8 over x to the 6th, and that fraction is raised to the 2/3 power. Again, there are a couple different ways that I could approach this. I'm going to look at applying that 2/3 power to each the numerator and denominator as my first step. So instead of 8 over x to the 6th all raised to the 2/3, I'm going to have 8 to the 2/3 divided by x to the 6th raised to the 2/3. Now, I have an expression that's just a number in that numerator, so I'm going to use the radical property and turn this into the cube root of 8 squared. And in the denominator, that x to the 6th raised to the 2/3, I'm going to multiply those exponents. So I'll have x to the 6 times 2/3. And in this next step, I'll finish simplifying. That cube root of 8 can just be 2, so that I have the cube root of 8 quantity squared. Now I'll have 2 squared. In the denominator, I have x to the 6 times 2/3. So I'll multiply 6 times 2/3. I can get 12/3, which simplifies to 4. So in that denominator, I have x raised to the 4th power. As a final step, I'll compute 2 squared, which is 4, and I'll get 4 over x to the 4th power.